We're still talking about Ohm's law, which is commonly written as V equals IR, and we're going to work through three simple example problems with Ohm's law. Now, even though it's commonly written this way, remember that there are other ways we can write Ohm's law. We could take the equation V equals IR, and we can divide both sides by R, as we did before, and when we do that, the R's cancel out on the right, and that leaves us with an I on the right equal to V over R. So instead of being written like this, V equals IR, it could also be written like this, I equals V over R. And there's another thing we can do. We can take the equation V equals IR, and we can divide both sides by I. And when we do that, the I's on that side cancel out, and we're left with R equals V over I. So Ohm's law could also be written like that. R equals V over I. These three equations are all mathematically equivalent. They're all really the same equation, just algebraically arranged differently. And we'll do an example problem with the equation in each of those three forms. Here's the first one. A 12-volt battery is connected to a light bulb with a resistance of 3 ohms. How much current flows through the light bulb? Well, the 12 volts, when it says there, that's the voltage. So I'm going to write V equals 12 volts. And it's connected to a light bulb with the resistance of 3 ohms. So that's the resistance, so I'm going to write R equals 3 ohms. And you see the symbol omega is the symbol for the resistance, for the unit of resistance, the ohms. And we're trying to find the current, how much current. So I is what we don't know. We can use the equation in this form. I equals V over R. And we just put in the numbers that we know for V. V is 12 volts, R is 3 ohms, and when we divide we get 4, and the current is in amps, and we use the symbol A for amps or amperes. In this example, we're told that a large electric heater is designed to draw 40 amps of current. And 40 amps is a lot of current. Just to give you an idea, I hooked up a meter to my stove. I have it's a regular electric stove with 4 burners, and I put them all on high. And with all burners on high, it was drawing 28 amps of current. So, and you typically don't run the stove with all 4 burners on high, but that gives you an idea of how much 28 amps is. Your electric stove, turn everything on high, that's it. So this is 40 amps of current. That's a large heater. All right, let's look at the problem. If the resistance of the heating element is 5.5 ohms, so that's the resistance R, 5.5 ohms, and we're also given here the 40 amps, that's the current. So I'll write I for current is 40 amps. And we're asked how much voltage. The voltage is what we're looking for. So we just use the equation in this form, V equals IR. So it's just a simple multiplication. 40 amps times 5.5 ohms, and it comes out to 220 volts. That's our answer. Now that's a lot of voltage. Now you might remember I said that a regular electrical household outlet has 120 volts. Or sometimes it's 110. So one of these outlets on your wall that looks like this is 120 volts. So you obviously couldn't plug this heater into that outlet. You need it to match. This heater is designed to use 220 volts. But if you go in your house and you look, say, behind your dryer uses a lot of electricity. There's a heating element in there and a big fan, and it takes a lot of energy to heat those clothes up enough to dry them. And there's a plug probably on the wall behind the dryer that looks something like this, and it's got 3 holes right there. And the plug on the back of your dryer that you plug into the socket is shaped to fit there, and it won't plug into a regular outlet. This is a 220 volt outlet. And most people have one of those in their home, and this is a 120 volt outlet here. So this, you could have a heater that runs on 220 volts, but you would need to plug it into a 220 volt outlet like this. Most of the stuff in your home, though, goes on the regular 120 or 110. And one more, when a certain light bulb is connected to a 1.5 volt battery, okay, so that's our voltage, V is 1.5 volts, 0.25 amps of current flow, so that's the current, and I is our symbol for current, and it's 0.25 amps. 0.25 amps of current flow through the bulb. What is the resistance? The resistance is what I don't know, so I'll use the equation in this form, R equals V over I, and I put in 1.5 volts and 0.25 amps, and I do the division, and it comes out to 6, and when you divide volts by amps, you get ohms, so this is 6 ohms. That's the resistance in this particular case.